Hey there, this is Mr. Wilford, and I just wanted to go through Chapter 5, Section 5 with you. And this section is all about indirect proof and inequalities in one triangle. And this is one of those sections that can be a little bit tricky at times, but just be sure to kind of read through the whole chapter and maybe take a few notes as you go through, and you might have to go back and even reread a few things here. What we're looking at here, as it says, so far we've written proofs using direct reasoning. So the flow of the proofs have been pretty straightforward, where we've kind of looked at something that we want to show that's true, and we've worked our way to that point. What we're going to look at here is something called an indirect proof, where you begin by assuming that the conclusion is false, and then you show that this assumption leads to a contradiction. So in other words, we assume that what we're trying to show is going to be false, and then we try to prove that, but there's a direct contradiction to that, and therefore the false conclusion cannot be true. So let's take a look here at a couple of things. First of all, there is a nice formal way to write an indirect proof. Number one, identify the conjecture to be proven. Number two, assume the opposite of the conclusion is true. Number three, use direct reasoning to show that the assumption leads to a contradiction. In other words, that assumption cannot be true. And then number four, conclude that since the assumption is false, then the original conjecture must be true. So the best way to kind of follow this is to look at this example here. Writing an indirect proof that a right triangle cannot have an obtuse angle. And so you can see here as you read through here, what we're trying to look at is this triangle JKL, and we're given that it is a right triangle, and we're supposed to prove that this triangle does not have an obtuse angle. So the first thing we're going to do is assume that it does have an obtuse angle. So we will let angle K be obtuse. Now if you follow along here in step 3, what we're doing is we're adding some angles equal to 90 degrees, and we're doing some math and solving really for the measure of angle L, which we end up solving less than 0 degrees. And so of course we know that an angle in a triangle cannot be less than 0 degrees. Therefore we would say that this assumption is going to be false. In other words, this triangle does not have an obtuse angle. Okay, so again, this can be a little bit tricky to follow. So you really want to make sure that you read through these a couple of times. What this kind of leads to here is some other angle-side relationships in triangles. A couple of theorems here. 551, if two sides of a triangle are not congruent, then the larger side or the larger angle is opposite to the longer side. So basically in a triangle, the larger angle is opposite the longer side. And this one kind of flows with that as well. In a triangle, the longer side is opposite the larger angle. So when you have a big angle like angle Z here, your side opposite that is going to be the longer side. So there's that correlation between the biggest angle and the biggest side in a triangle. Again, there are a few other examples here that you want to check out. Make sure that you read through those. And then finally, this theorem here, 553, triangle and inequality theorem, which basically is going to tell us that the sum of any two side lengths of a triangle is greater than the third side length. So in other words, when we add the length of two sides up, it's going to always be greater than the third side. So you can see there that they supply each case here for that. All right, again, if you have any questions, please let me know. Thanks.